Hi everyone, how is everything going? This is Chloe. I'm founder of CFG Labs. We are building the best builder developer community, for the modular world. For myself, I'm developer, content creator, but most of my career as an angel investor back to 2016. I'm actually, from studying, mathematics, economic research from UCL and Cambridge. Today, we're very honored, to invite, Neil Salami, founder of, Eclipse, one of the most, innovative modular projects trying to bring in, Solana VM, Celestia DA layer. Who just steal the big money from top investors like Polychain and Solana Foundation. Hey, Neil, how is everything going?
Hey, going well. Thanks for having me.
Yeah, good. So, we have seen a lot of infrastructure innovation during the past 6 years. Lots of projects trying to improve latency, finality, and throughput, but with sacrifice of decentralization and also security. But I believe we are now in transition to the next improvement and next big huge opportunities. So before we deep dive more into that, could you please make a self-introduction of yourself and what's the progress?
Yeah, so I'm Neil Samani. My background's in traditional finance. I was working at Citadel. I was in the commodities group, working in the power and gas group. So that was mostly, it was basically entirely non-crypto stuff, looking at different kinds of market structures, modeling out what the power price would end up being. But it's actually very relevant to crypto now that people are doing things like frequent batch auctions and all kinds of different market structures. So I quit in March. I was briefly building in the Terra ecosystem. I was building an EVM, so that's a way to run Ethereum code on Terra. And obviously Terra depegged, scrapped that project, chatted with the Celestia folks throughout June, and then basically started buying into the Celestia vision of the future, which is far more scalable and leads to a more decentralized future than the direction that things are heading in right now with this cycle of L1s. So I was in Chicago at the time, chatting with the Solana core team, and I was talking with some protocols that were hitting some scalability issues on the Solana blockchain itself, despite Solana being one of the fastest chains out there. Basically, they were using up 10% of the network. For example, Pith, it's an Oracle and Solana. They recently had to spin out as the first ever Solana app chain called PithNet. They have to run the infrastructure themselves. They have to maintain the reliability. And I think they're really regretting that because at the application layer, they really shouldn't be thinking about things like that. So that's the problem that Eclipse is solving. It's that applications need more throughput. They want to have complete control over their stack. And this is basically what we offer with these customizable modular rollups that use the Solana virtual machine. So you get the Solana virtual machine, you get all the throughput that provides, but you also get to choose where you get security from. So we're starting with Celestia because Celestia is the best data availability layer. We'll support Solana. We'll support a bunch of other DA layers as well.
That's cool. That sounds really impressive to me, but actually I didn't see very too much open public information. But I believe there is something we can talk about today. So I really like the mix match, a modular, engineering design from your side. Also, surrounding community, and I believe, there's a minimized, honestly, validator nodes assumption during the, trust minimized environment you mentioned previously. So, everything, is very interesting. So I want to talk more about, Solana point of view. Solana is something actually, we have been, researching for a long time. And I think, they have supported many, great, top DAX. One of the largest NFT market plays, the Magic Eden. And so, what do you think of Solana's future potential? Either from engineering design point of view and its ecosystem and the user point of view.
Yeah, so I think that the Solana virtual machine is basically the best execution layer out there, and that's why we're choosing that, and that's why we're starting there. In fact, the earliest versions of this project involved us building our own bespoke virtual machine, and we were basically designing it from scratch. It started looking very similar to Solana. And then once Anatoly Angel invested, Solana Foundation gave us a grant. We're like, given this incredible support that we're getting from the Solana ecosystem, does it make sense for us to build a virtual machine from scratch? So that was the thinking there. They have this great fee market that's coming up. They do parallelization across transactions. They use GPUs for signature verification. There's all sorts of fancy stuff that the Solana execution layer does. But the trickiness is that Solana isn't really built to be a rollup. and that one, the repo itself is monolithic. It doesn't totally factor out consensus from execution. And then the other part is that there are no light nodes in Solana, which is typically you want to have something where you can do like very cheap verification of Solana transactions, but that's not a thing. So we have to do like substantial changes to the Solana code base in order for it to work with our infrastructure.
I think scalability of Solana actually tries to do in 3 points. So the first part is like efficient use of bandwidth, and then it tries to reduce like overhead like communication between different validators, and also it tries to like improve the execution between different environment. POH is something very interesting to me because it provides actually the really like immutable like censorship resilience like global clock for other like inputs and messages, which try to improve like propagation experience among the Turban protocol block, Turban propagation block protocol as well. But I think there are still like some existing problem, for example like frequent like collapse of lead validators and like MEV attack like for Solana as well. The use case actually, to be honest, I'm big fan of like gaming and like socials. Like we have seen so many like different like gaming and social iterations during the past 6 years. I mean, Placer is very interesting, but actually it looks like it's not sustainable. But I believe right now there are still like lots of like different startups, founders are trying to iterate, innovate in the space. Asia actually takes care of over like 55% of this market share right now, and I believe this region has like still like has like huge potential like to improve in the future. Besides like gaming, I think NFT is also interesting. It really provides like tokenization of different assets like art, like in-game assets, and also like real estate, etc. They're actually like ownership of people and skill on the blockchain actually provides a new mechanism for digital right management. So I think there are some like great projects right now building on the Celestia ecosystem, like naming service and other DID projects, which actually will bring like a new, absolutely real digital and data privacy for the real world, for the Solana community. So I think Solana is great, but but there are also like some problems I mentioned. For example, the validators, frequent clips, and also like MEV attack. So what do you think? How Eclipse is trying to solve this kind of problem?
Yeah. So just to like kind of go in order of how you said it. So for some of the optimizations that you're mentioning, like you mentioned turbine block propagation. We don't use that, given that there's only one leader in our. Actually, sometimes we're starting with a single sequencer, so there's like no one to like propagate the block to, if that makes sense. Like the sequencer produces a block and it's stored in its entirety on Celestia. So like we don't use turbine. Proof of history, like the purpose of that in Solana is basically decoupling execution from consensus in like a very structurally similar way to what rollups do. So like we obviously don't have proof of history. And then the last point was sea level, which we use. And then when you're mentioning like the issues with the Solana, I guess like Gulfstream is what you're alluding toward, where they remove the mempool and they forward a transaction directly to the leader. We actually have a mempool. So like we basically, some of these optimizations we don't need for Eclipse, given that the real unlock for Eclipse is the fact that you can horizontally scale and each application gets its own execution node. So yeah, I also think that like things like the fee market, they just recently switched to Quick instead of UDP. Like Solana is obviously addressing some of the liveness issues on the L1, but we're actually hitting the long tail of applications that can't be run on the Solana L1, even if it ran correctly. So that would be stuff like when you mentioned like the NFT projects that are on Solana. I think they're there typically because Solana has low fees. But an NFT project, if you really wanted to optimize for it, you'd even start modifying stuff in the sequencer. For example, you might slow down block times for an NFT drop because you don't want bots to pick up NFTs because they're a little bit faster. Or you might do things like you'd apply some sort of like batch commitment scheme where when a bunch of people try to buy an NFT at the same time, you have some concept of fairness, and then you fill those orders in some reasonable way. So these are things that like on the Solana L1 you can't get those features anyway. But yeah, we're actually borrowing a lot of that NFT infrastructure, and several projects from Solana are coming to Eclipse.
That's great. What you just mentioned is kind of, actually, is what I actually thinking these days. So I think, for the example, the validator, like for Eclipse, I believe, that's because like validator actually produce like blocks very fast. In that case, they don't actually wait for the entire, whole consensus the procedure to complete. So like sometimes the follower like validator catch that speed, which actually result in this kind of problems. The average block production time in Solana, I believe is like 1 second, like vs like Ethereum like 12 seconds. But I believe like some projects like Aptos and like Sui are actually trying to reduce the block time right now, trying to solve this kind of problem. I think Solana, for the Solana MEV problem, I think you mentioned it's great to like especially point out two parts. The first one is like there are like no gas fee mechanism on Solana, so actually every like searchers like keep submitting repetitive like submission like transactions to lead validator, so actually their transaction being added like during like for example like NFT minting or like huge like from running opportunities. Second point, I think it's what you mentioned, you actually consider like include member pool, which is great. Member pool less environment transaction actually can't be like efficiently filtered out among those bloom filter mechanism on Ethereum. So in that case, also like on Tendermint like validator are normally like selected in advance, so they are also like publicly known, so which may like produce a lot of like this kind of problem as well. I'm learning a lot. So the next question, I'm curious, like what kind of technology you mentioned, because you just mentioned you actually like Eclipse is trying to provide a very trust minimized, like multi-chain like world, like for differently route, as a like infrastructure as a hub. So I would love to dive on the technology, point of view.
Yeah, I mean, the first part is that it's a different type of rollup. Like, people will describe their rollup as modular, but they don't necessarily know what that even means. And the big unlock is that we don't do settlement on chain. So we have our own settlement layer, which is built for the Solana VM. And that's one feature. The second feature is that we have a few projects underway. Aside from that, we have a zero knowledge Solana VM, and we're going to be the first ones to bring that to market. And then we also have, we've enabled IBC for the Solana VM. And that's actually the condition for our Solana Foundation grant. So those are like the kinds of tech that we're building up right now. And yeah, I guess a part of implementing like the settlement for the Solana VM means that you have to somehow get it to work in the parallel environment that the Solana VM operates in, which is different than the EVM, which is single threaded. So it's a lot simpler to implement optimistic settlement for an EVM chain.
Okay, I want to like give an example of like some of our like portfolio. For example, like DY mentioned, they actually introduced like something like similar to IBC, IBC Pro like based protocol, trying to like within their own like raw environment rather than like consumer chain or like Cosmos chain and APP chain in Cosmos ecosystem. Also, like they introduced something like similar, something like called like RVM, which is very interesting. Actually, on the settlement layer, you can speed up like different like RVM, and which is trying to implement different multiple like rollup execution environment. So for example, if you are rollup actually like more like a Solana VM compatible, but you don't have to permanently add like Solana VM logic on the settlement layer. RVM actually, I mean it makes sure like rollup built on top of that can always like evolve and keep up with latest update of the technology, and especially from execution environment point of view. Definitely, I believe there are some like more like interesting part from your side as well. But right now, it's not something we can't disclose right now more, but I definitely look forward to that in the future. So,
so this is like a light paper that was iterated on with Mustafa and the Celestia team back in June. So it's actually predates some of these other projects. But yeah, Dimension and Atria, which is spinning out of Celestia, are both EVM settlement layers.
That's cool. Look forward. So yeah. So now we actually want to talk more about like economic value accrual, for the future. So MEV and value accrual has always been a very interesting topic. So before we dive more into that, I want to learn more about like detail about actually how Eclipse try to value accrual.
Yeah, I think the way to think about value accrual in a modular world is like first contrasting it with how it looked in a monolithic world, where there was just one protocol, like one L1, and all the applications lived there. And if the L1 really jacked up the fees, there wasn't really anywhere for the application to go, because that was basically their only choice if they wanted to pick like a maximally decentralized or like a particular execution layer. And now it's like it's gotten to the point where you can, especially in a world where like everyone shares the same data availability layer, but you have multiple execution layers, then you can actually switch the data availability layer very easily. So in that case, it's not that like no value will accrue to the data availability layer, but it's not quite like perfect competition. But the data availability layer needs to compete on some other attribute, whether it's like the level of decentralization, the sophistication of their data availability sampling. They might, there might even be data availability solutions that are completely centralized. Like, for example, you can imagine if there were some sort of on-chain Twitter might provide the data availability solution and just charge a ton of, they might just like charge no money basically, as they're competing on price. Because the argument would basically be that like no one actually reads the smart contract anyway when they're interacting with the protocol. So you're already implicitly trusting Twitter. You might as well trust them to store the data for your blocks as well. So that I think that's what we're gonna end up seeing in data availability. There'll be like a variety of solutions that are like maximally decentralized and very expensive versus totally centralized and very cheap. So then you have to think about like settlement and execution and where does the value accrue between those two. Settlement is basically based on network effects. The more chains that share a settlement layer, the more valuable that settlement layer becomes because you can move money between the chains. And then execution, it depends on the moat that the execution layer provides. So like Starkware, for example, is closed source. I don't know if I agree with that, but the fact that they can argue that they have like some more sophisticated ZK proving technique. They have a bespoke VM, Cairo. So once you write code for Cairo, you can't move it anywhere else. And as a result, if they charge more for that execution layer, you basically have to pay it. So those are the kinds of execution layers that'll accrue value in the long run. Something with either like some technical edge, there's some stickiness on why, like, if you build an application for one chain, you can't just deploy to another. So maybe like a super fast virtual machine or execution layer could accrue value because maybe there's a game that uses up all of the throughput. They can't just move to Ethereum because Ethereum doesn't support the level of throughput that they need, and therefore they can charge more. So those are the types of ways that the execution layer can gain pricing power.
Yeah, that's cool. I'm actually quite familiar with, like Starkware ecosystem, and, I think, they're actually building, Cairo language as well. They are also like, but I believe, there are some team, and there is one called, slash SDK that are trying to like, integrate it to, ABCI and Tendermint. So actually, expand into Cosmos as well. And, I think, like, Asian security, is very interesting because, here I want to mention about, DA security and like consensus security. So I think Celestia work as the DA like security, right? So it's kind of like similar to Cosmos how, like interchain security, they provide validator, provide like security like to the consumer chain and you get like incentivized by the consumer chain. So I think the DA nodes on the Celestia should be incentivized as well. But right now I think only like I think on the storage node on the Celestia I get properly incentivized by storing data. But I believe every like settlement layer and rollup built on top of Celestia should incentivize should like distribute a percentage of their revenue like profits to Celestia in future, and I believe that well structured like economy should be built out. It should be designed from the community. I think you mentioned a lot of like we should have multi like DA solution for the future from security and like cost point of view in order like for different like roll up settlement layer to choose from. Agree that if Celestia kind of like DA solution like Celestia also allows like segregating different like markets for the fee market, which actually tries to improve like efficient resource pricing problem when normally stay in a monolithic world. And other solutions like for example agent layer is great, it's amazing, it's a platform to leverage like Ethereum's like security, tries to introduce like more like innovative like method for risk taking. So I think for Eclipse, like too much details, but you mentioned some ideas, that's great. But I think there are still like some points we should think about. For example, for example, if you believe there are strong value accrual, like as more like DAPP, like developer, coming into the Eclipse. So built on top of that, transaction are definitely paid by the users, right? And there should be, the fee like for the IPC, like similar interoperability between different rollups. And, as a sequencer, I have always, need to like submit, data and like block roots, state roots and the blocks, to the DA layer and the standard layer. So I have to pay. And also like as a sequencer, I need to secure the network. So I have to, stake percentage of, the token, to the network. So that's something, some direction that I'm thinking through.
Yeah, that's all correct. Yeah, you charge for all of it basically. So the parts that we provide are like execution and settlement. So you charge for that. And the expenses are basically having to post the block of data to the data availability layer. So but I mean, you can also get additional revenues too, right? Like if you were working with Skip, they're basically going to be able to capture the MEV produced in our blocks and then return it back to our execution layers. Or maybe if there's an application, if it's an app-specific execution layer, then that app can actually benefit from the MEV that's being produced.
That's good. I'm going to mention in the last part as well. Yeah, so I want to talk more about like last question. I want to talk more about like future of MEV. Can you give expectation for the future?
Yeah, so it's like different kinds of MEV strategies that would emerge now. Because before, I think an MEV is probably more sophisticated in a completely monolithic chain where all the applications live together, just because there are more opportunities. But when you only have one application on a chain, then, I mean, it's hard to say like how to end up looking at something that I'm sure Skip has looked at more. In terms of the MEV that's available, it's probably pretty highly correlated with just like straight transaction volume or like unsophisticated transaction volume. People who are just like trading against the chain, but they're not necessarily setting the slippage to the exact value that they're comfortable with, something like that. So, yeah, that's something that MEV is more of an opportunity for us because we can capture the MEV as a protocol and return it either to like the Eclipse protocol or back to the applications that are building on us. So yeah, it's not something that's like that we're primarily concerned with.
Yeah, that's good. At recent like Ethereum developer conference, I believe Terran Garnet network provides a very like interesting topic about ME theory. For example, how to balance like equilibrium from social welfare point of view, from the validator's point of view, between like how to maintain like economic security from either like validator point of view. So actually, right now we have seen like different kinds of MEV like arbitrage, like liquidation and like NFT from running, cross-chain, etc. But it's very hard to tell which one is good or right. Like for example, like sandwich attack can also sometimes increase social welfare, but like for some like a good MEV, for example, like liquidating time, although like they try to improve the execution experience from the trader point of view, but it actually sacrifice return and benefits from the passive liquidity provider point of view. So I think still lots of like different concern and something to be solved in the future. And some projects, as you just mentioned, like Skip protocol, I think they're very interesting. And try to bring like a cross-chain MEV solution to the customers. Some of like existing problem, like for example on Ethereum is around like for the PBS, it's like some validator trying to include like toxic MEV transaction, which is not good for the users. So actually they're trying to find a way to solve that problem. Also they are trying to like bring like I think like on-chain flashball, a version similar kind of like solution to the industry. So I'm very excited about that. So yeah, I think time is up. It's a very nice talk, and I think it's very very like interesting discussion between us, and definitely all the best for the Eclipse in the future, and look forward to talking to you next time.
Good stuff. All right, thanks, Chloe. Bye.
Bye.